In this video, we are going to be discussing question number 6.22, or if you have your old textbook, it's going to be 7.22. So this question is also again related to the ionization of weak bases. Definitely check out that video for so you have. Also, I would recommend doing the acids first, because acids and bases, the explanation is pretty similar. The concept, the basic underlying concept is the same. It's just that we have a different constant for the acids and a different one for bases. Okay, so definitely check out those things. So 6.22. Calculate the pH of the solution in which 0.2 molar NH₄Cl and 0.1 molar NH3 are present. The pKb of ammonia solution is 4.75. So we have been given the concentration, or the initial concentration, of NH₄Cl is equal to 0.2 molar. Concentration of NH3 is equal to 0.1 molar, and we've been given the pKb for ammonia is 4.75. So what do we need to do? We need to calculate the pH. Okay, so what we're going to do is we're going to first take the equation itself. So the equation NH3 combines with water, ammonia plus water, gives rise to NH4 plus OH minus. So essentially this NH4Cl is there, right? That's essentially what this NH4 plus represents. It's the ion. Okay, so first let's write down the initial concentrations. So initially the concentration of NH3 is 0.1 molar, concentration of NH4 plus is 0.2, and concentration of OH minus, we're going to assume it to be 0. And the change in concentration is going to be minus X for NH3. For NH4 it will be plus X, and OH minus also it will be plus X. Right, it's the same thing. It's the exact same thing as what we do for acids, right? So at equilibrium, the equilibrium concentration is 0.1 minus X. For this one, it's going to be 0.2 plus X, and then for the OH, it's X. Okay, so this is the concentration of all of these at equilibrium. Okay, now, first of all, we've been given the value of pKb. Okay, so from pKb, we can calculate the value of Kb, right? So pKb is minus log Kb. So this value has been given to us. It's 4.75 is equal to minus log Kb. So obviously negative sign can move that side, and when we take the anti-log, you get Kb equal to 10 to the power minus 4.75. Okay, when we take the anti-log. So that is equal to 1.778 into 10 to the power minus 5. Okay, so this is the value of Kb. Now, I know you know what, you can just pause over here and try and solve the question. I feel like I've given you enough clues, and try and solve the question. And if you're able to, that's amazing. Good job on you. And if you're not able to, that's perfectly fine too. I'm here to explain how to do it. So, you can just pause and try and figure out from here. And if you don't want to, stick it out. That's perfectly fine. So Kb is equal to concentration of NH4 plus into concentration of OH minus, whole divided by concentration of NH3. Okay, so this will be equal to 0.2 plus X into X whole divided by concentration of NH3, which is 0.1 minus X. Okay, and this is equal to 1.778 into 10 to the power minus 5. Okay, so first of all, if you notice, the value of Kb is significantly small. Okay, so because of that, what we're going to do is we're going to ignore this value of X and this one because the dissociation has not happened to a great extent. The only reason we are able to make these concessions is because the value of KB is so small. The dissociation does not happen to a great extent. And so we are assuming that the value of X in this point, at this point, is equal to 0.1 minus X is approximately equal to 0.1. So essentially what we're doing is 0.1 minus X is equal to 0.1 because the value of X is going to be significantly low because we've seen that this KB is so low. Okay, if it had been a strong base, we would not be able to do such things. Okay, so you are going to be assuming, so 0.2 minus, oh, plus X is going to be equal to 0 point, approximately equal to 0.2. So we're making these assumptions. So we are going to be left with 0.2x divided by 0.1 equals to 1.778 into 10 to the power minus 5. Okay, now this is basically 0.2x equals to 1.778 into 10 to the power minus 5 into um, or actually, let me do it this way. We can just use 0.1, 0.2. So it'll be basically 10 to the power minus 1. This goes to the numerator, becomes 10 to the power 1. So, or you can multiply 10 for both the numerator and denominator. You're left with 2x. Okay, so 2x is equal to 1.778. So x will be equal to, let me scroll down a bit. So x will be equal to 1.778 into 10 to the power minus 5 whole divided by 2. And this is equal to 0.889 into 10 to the power minus 5. So this is the concentration of the OH minus ion, right? So this is the OH minus ion. So first of all, I know in your textbooks they've just jumped and they've given you the value of concentration of H plus. I found it easier to do it this way. Again, if you find it easier to do it that way, go for it. But what we're going to do is we're going to first figure out the value of POH. Okay, so POH is equal to negative log concentration of OH minus, right? So what we can also do is I'm just going to switch this, or actually I'm just going to leave it as it is because that's what I did in the past. So we're just going to go forward. So minus log 0.889 into 10 to the power minus 5. And this is equal to minus log, we're going to simplify log A into log B is log A plus log B, right? So log A is 0.889 plus log 10 to the power minus 5. And then log 0.889 is equal to 0.0, oh, let me just rewrite this, is equal to 0. Log 0.089 is minus 0.051, and then log minus 10 to the power minus 5 is log minus 5, and this on addition, this is going to get added, and then you have a negative sign. Minus into minus is equal to plus. So you are left with plus, the POH is 5.051. Okay, now from a couple of videos ago, we know that POH plus pH is equal to 14. Okay, the reason we did it this way is because it gives me, there's less math involved, right? So POH is 5.051 plus pH equal to 14. So pH will be equal to 14 minus 5.051. This is equal to 8.949. And I'm pretty sure this is super close to what is given in your textbooks. So what all we did was we started this question with we had to calculate the value of pH. So we've been given the value of concentrations of NH4 and NH3. And then we first calculated the value of Kb and then we use the equation for kb to get to this point. We basically ignored the value of x for here and here because it's significantly small, because the value of kb is so small. Okay, it's a weak base. Because of that, we were able to do that. And then we figured out the concentration, the value of x. Now, the value of x is equal to the concentration of OH minus. All I did here was I used the POH equals to minus log concentration of OH. I calculated the value of POH, and we know pH plus POH is equal to 14. So from there, we were able to calculate the value of pH. Okay, if you have a different way of doing this, definitely let me know. With that, we're done with calculation of this particular question. I honestly did not check what I'm going to be teaching next in the next video, but it'll be in the, in the end screen if you have stuck around this long. And definitely let me know if this video helped you.